So today I have a basic Jacob's ladder set up using two coat hangers that have been untwisted and set up here. And I wanted to show the effects of different current limiting mechanisms. This MOT, I'm using an old power cord from APC, uninterruptible power supply. So it has a 15 amp thermal fuse. Very handy because this will pop well before the 20 amp breaker feeding the circuit will. So I'm just going to leave that on there. We're going to use that as extra safety. These are capable of pulling well more than 20 amps. They will definitely pull enough to pop a breaker, and they'll get quite hot after doing that. So as is tradition, by the way, I had this cord over here, but always make sure this is within sight and unplugged before you're interacting with one of these. There is no forgiveness. So the way that this works, I didn't explain it in the last video because I assumed you'd probably see other videos, but the chassis is one side of the secondary. The other side of the secondary comes out through here, and then you have two fat leads, and these feed the filament on the magnetron. These are low voltage, useless for our purposes, so we're interested in the high voltage from the microwave transformer. So case is one lead from the secondary, and the other lead from the secondary is poking out here usually. And you can actually see where the case is bonded. Let's see if I get this on camera here. This is where the case is bonded, and you can actually separate this. This has a lot of utility when you find ones. These are much more valuable for reasons I won't get into this video. If you can detach that and use that. So these are a bit more valuable. So if you find one of these transformers like this that has a case bound you can undo, that's a golden one. So like I said, I've got my current detector here. We're going to see just how much we pull on a couple different mechanisms. So I've got a piece of PEX tubing here I'm going to use for interacting with the rods, and this is not going to be enough voltage to have a self-sustaining gap without capacitors or other circuitry involved, at least one MOT. But it will give you a nice fat arc if you use it straight from the wall, and we'll talk about that. So what you're going to have here, though, these two bent coat hangers, and again, let me double check. We're going to always be paranoid. Let's see, hold the cord goes to thing, right? Okay, now I'm going to interact with the rods. So you've got the two rods here. Each leg is going to one part of the secondary. What I've done, though, is I've taken two wood shims and just smashed them in the vise. No need to drill or do anything fancy. This doesn't have to be a fancy thing. You can set one of these up in seconds, which is what I did here. I spent no time on this. If you haven't picked this up, by the way, most of my videos, I'm trying to make them speedy, fun stuff. I'm doing this in some free time I've got in the afternoon after putting some kids to bed. It's not like I'm going to spend hours making a video. So if that's what you're looking for, there's plenty more channels that do that. This is like quick and dirty stuff. You want to do something fun, make some sparks. This is a good, safe way to have fun with it. Safe in quotes. I'm sure someone else could always be more safe by having you play with, food coloring in water or something. So this, I made that joke. There are actually some really cool laminar flow videos. We're going to start off by going through the current limiter we built. We're going to plug in Mr. Transformer. And the other lead to this is going to go into our non-isolated variac. I need two hands. Give me 1 second. Okay, now that I've plugged that in, we'll kick on the variac. So power now will be going through the space heater in the back and then into the MOT like we talked about yesterday. So I'm going to kick this guy up and we're going to turn power. You can hear it hum a little bit. And so with the space heater running through the transformer and the secondary just sitting there with nothing going on, we're pulling 3.6 amps. Okay? And I'm going to do a full short, and it's going to be very disappointing. Okay? Because I don't want to harm the variac. Its max output is 9 amps, or 5. I'm going to turn it off, to cut the power completely off here, and I'm going to unplug this. We're going to go straight into the wall outlet with this thing. So let's just take this little guy. We're going to unplug this. So one cord at a time. Give me a second. All right, so again, now we're plugged straight into the wall. So the power for our current limiter is going straight from the wall. We're not going through the variac. So we're getting a full 120 volts and capable of up to 15 amps before that thermal pops on the primary down here. So this guy will pop at 15. So we're going to short this out. And there we go. Space heater fan is running. Pulling at 9.27 amps, 9.26. But look how boring that arc is. That's pretty sad, isn't it? Not a whole lot going on there, huh? So that's useless, right? So we talked about inductive current limiting the other day. Keep in mind this thing's still charged, so we're going to go over here and unplug it. There we go. The humming has stopped. I'm holding the cord and validate again. That is indeed the cord we're working with. Let's use the back of hand, because reflex would be to grab. So if you use back of hand, you'll pull away. So back of hand anytime you're checking things. I also didn't mention that in the last video. You don't ever grab anything that could ever be electrically hot, even when checking AC motors. If you ever worked in an industrial environment and you want to check temperature on a motor, you never trust that the casing is properly grounded. You can use the back of your hand, hover over the device, make sure you're not going to burn yourself, and you can kind of touch a little bit. Always use back of hand, because the reflex is to pull away. Never use this, because you don't want to grip, especially with 277 and up, which we're not dealing with here, but just good practices to have. All right, so we're now going to take and do the dumbest thing. We will connect this guy straight in. And if I can get this pulled loose, Lord almighty. All right, that's a good brand new outlet, that's why. All right, now we're going to plug this guy in. Let's see here. Bump. That makes a nice hum with my safety glasses on. All right, and we're going to watch the arc. We're pulling 7 amps just sitting here. So just 7 amps going through the space heater of that. Or that's actually going straight through the transformer, no space heater. That's pretty, isn't it? Now it's a thermal fuse, so what's going to happen is it's going to overheat here pretty quick. So, yep, that was it. So the thermal fuse tripped after a couple hits, and so we are pulling over 15 amps. So I'm going to de-energize the circuit by reaching over and unplugging the cord. Cord is in control again. I can reach over and pop this thermal fuse back. Yep. So get some nice arcs going straight from the transformer. Here's some things you could do to get better arcs. You could drive my old setup with my old one back in the day, I used 2 microwave oven transformers with the primaries in parallel. So you've got power coming in and power coming into both primaries. And then this is where you can get creative. You can wire the secondaries in series if you so choose. It could shorten the life of your oven transformer because the windings aren't rated for that voltage. So basically you'd come out of one transformer and go to the case of the other, and then come out of that one. Just like hooking batteries in series. You hook the output of the transformers in series, and you up the voltage. You can do that, and you can draw some beautiful white hot arcs. I'm not going to do that because it will instantly pop this, and I'll definitely pull more than 20 amps. And I don't have my shop right here, this desk, to set up for more than that right now. I've got a single 15 amp, well, 20 amp service available for this desk. All my shop stuff is on the other side, and I've got a vehicle parked in here right now. So, but yeah, that's doing very basic Jacob's ladder. It doesn't take a lot to set one of these up. But if you're wanting to do this with 1 microwave oven transformer, you're probably not going to be very happy. You're going to need at least 2. But I tell you what, let's come back and show what a neon sign transformer does, because it's a lot more fun to set one of those up. So let's come right back with that. And here's an example of a neon sign transformer. I've shoved a piece of wood in to keep the rods from vibrating, which is less than ideal considering it's flammable, but it's all right. And so I want to show you something. I'm going to show you the current draw on this while it's running. Does that look like a lot of current to you? The answer is absolutely not. Okay, with the transformer still on at full power, I'm going to short it out. 1.4 amps. So I want you to think about something here. This is why neon sign transformers are so fun. It's because they're internally current limited. You get a higher voltage and it's current limited. I'm doing this with the pole right now because I've messed up how I had these things aligned. This transformer secondary is, what is this guy? This is a 5,000 volt. So you'll find 7,000 volt and 15,000 volt. I've got a much bigger neon sign transformers in stock, but again, let's go with basics. This is a 5,000 volt neon sign transformer. You can see that if I used thinner wire and was very careful about spacing, you get that classic sound and a very nice arc. You can do that darn near all day long and it won't hurt the transformer. I'm going to kill the lights in here. There you go. And let's arc it out again here. Find it with the pole in the dark. There you go. So if I had that going through a bigger transformer, you'd get a little bit more of a light show. You know what? Let's just do that. Let's go grab you a bigger one. Now, these are my personal favorite transformer of choice. This is an oil burner ignition transformer. This was new old stock from March of 1988. You can still find these, rarely, and albeit somewhat costly. They are also current limited, darn near indestructible, so really good for Tesla coils and other high voltage projects. A very nice, really well designed, because they can just, I don't want to say they're continuous duty, but they basically are set there to darn near be continuous. I'm going to turn on our variac, start turning the voltage up, and you're going to see an arc as the voltage goes up. Remember, this is on the primary winding, right? So it's not secondary voltage, it's in the thousands of volts. How about that? Oh. Sometimes when you get an arc there, it'll hold the poles together. All right, let's turn the lights off. It's a better light show. Okay, so let's bring the voltage up slowly on the variac. That's full power. Well, not when it's holding the poles together. Come on. There we go. It would be when I turn the lights out, it decides it's going to do this. Let me grab where's my stick? My giant PEX tube. There we go. How's that? The current draw on this is also very small. So that's 10,000 volts. You were previously looking at 5,000 volts. So you can see the difference the voltage makes in being able to cut this gap very easily. That's a good hot spark too. See if I can bend that with this pole just a bit and get it set for a little. There we go. As you can tell, doing this is the hardest part, and I can use this PEX tube to sort of bend it and get it set. But for an easy self-starting Jacob's ladder, oil burner ignition transformer is your best, in my opinion. It's current limited like a neon sign transformer. You can still find them relatively cheap. They give you a nice 10,000 volts. It makes it where it automatically starts really easy, and they're darn near rated for continuous duty, so it could do this just about all day. They're equally dangerous to a neon sign transformer, because 30 milliamp at 7,500 volt or even 5,000 volts is going to kill you across the chest. So you're always careful when working with high voltage, since I'm using an insulator to interact with this. Oh, camera's having a lot of trouble. Come on, get the arc. Well, thank you, Android. Turn the lights back on here. And so if you've seen anything from this, I hope you've seen, if you're trying to pick between high voltage sources for a basic Jacob's ladder, the oil burner ignition transformer is your best friend. And this thing will be, well, again, see, make sure I'm doing this on video so that people can see. You grab the cord, validate, is it indeed the cord going to thing? Yes, it is, and check. Stone cold, not a lick of heat. So that's kind of what we expected. I didn't show the current draw. It's also negligible. So using a current limited source like an oil burner, though, that's going to be your best bet if you want to do a basic Jacob's ladder. No frills, really easy to build. You can do it with MOTs, with combinations of MOTs and capacitors, and have it be self-starting. There are other videos on that. Again, this is meant to be if you want to do a quick KISS project where you want to get some sparks and arcs. This is a real quick way to get started. This is something I would have wanted to see whenever I was younger. So there you go. Hopefully you all enjoyed that.